Neural networks are a fascinating area of artificial intelligence. They have revolutionized the way we approach complex problems and have opened up new possibilities in various fields. They are inspired by the structure and function of the human brain, which is an incredibly complex and efficient system. Imagine a computer system that learns and makes decisions like we do. This is the essence of neural networks. That's what neural networks are trying to achieve. They aim to replicate the brain's ability to process information and learn from experiences. They are designed to mimic the way our brains process information, allowing for more natural and intuitive interactions with technology. At their core, neural networks are a type of machine learning algorithm. They use data to train and improve their performance over time. They consist of interconnected nodes, similar to neurons in the brain. These nodes work together to process and analyze data. These nodes process and transmit information, allowing the network to learn from data. This learning process is what makes neural networks so powerful. By adjusting the connections between nodes, neural networks can improve their performance on specific tasks. This optimization is key to their success. The beauty of neural networks lies in their ability to learn from experience. They can adapt and improve over time, just like humans. Unlike traditional computer programs that follow explicit instructions, neural networks learn from data. This makes them more flexible and capable of handling a wide range of tasks. They identify patterns and relationships in the data, enabling them to make predictions or decisions. This ability to recognize patterns is crucial for many applications. In essence, neural networks are powerful tools that allow computers to learn from data, make predictions, and solve complex problems. They are at the forefront of AI research and development. Their applications are vast and continue to expand as the field of AI advances. From healthcare to finance, neural networks are transforming industries and driving innovation. Imagine a network of interconnected points, much like a web. This web is a simplified representation of a neural network, a fundamental concept in artificial intelligence and machine learning. That's the basic structure of a neural network. It consists of numerous nodes or neurons that are interconnected in a specific manner to perform complex tasks. These points are called neurons and they are organized in layers. Each layer has a specific role in the processing of information. Each neuron receives input signals, processes them, and sends an output signal to other neurons. This process is akin to how neurons in the human brain communicate with each other. The first layer is the input layer. This layer is responsible for receiving the raw data that the network will process. It receives the raw data, like pixels in an image or words in a sentence. This data is then passed on to subsequent layers for further processing. The last layer is the output layer. This layer provides the final result of the network's computations. It provides the result, such as the identified object in an image, or the translated sentence. The accuracy of this output depends on the network's training and the quality of the input data. Between the input and output layers, there can be one or more hidden layers. These layers are crucial for the network's ability to learn and generalize from the data. These layers perform complex computations and feature extraction. They help the network to identify patterns and make sense of the input data. The connections between neurons have weights, which determine the strength of the signal transmission. These weights are adjusted during the learning process. During the learning process, these weights are adjusted to improve the network's accuracy. This adjustment is done through a method called backpropagation, which helps the network to minimize errors. The structure of a neural network with its layers, neurons, and connections allows it to process information in a distributed and parallel manner, similar to the human brain. This parallel processing capability is what makes neural networks so powerful and efficient in handling complex tasks. Neural networks learn through a process called training. This training process is fundamental to how these systems operate and improve over time. During training, the network is presented with a large data set of labeled examples. These data sets are crucial as they provide the necessary information for the network to learn patterns and relationships within the data. These examples consist of input data and the corresponding desired output. The input data could be anything from images to text, while the output is what the network aims to predict or classify. The network adjusts its internal parameters, the weights, to minimize the difference between its predicted output and the actual output. This adjustment is a continuous process that happens over many iterations. Backpropagation is a key algorithm used in training neural networks. It plays a critical role in how the network learns from its mistakes. It propagates the error signal back through the network, allowing the system to understand where it went wrong. This allows the network to adjust the weights of connections between neurons. Each adjustment helps the network to make more accurate predictions in the future. By repeatedly processing the training data and adjusting the weights, the network gradually improves its accuracy. This iterative process is essential for the network to refine its predictions. The learning process is iterative and requires a significant amount of data. The more data the network processes, the better it becomes at recognizing patterns. The more data the network is trained on, the better it becomes at generalizing to unseen examples. This ability to generalize is what makes neural networks so versatile. The ability to learn from data is what makes neural networks so powerful. This learning capability enables them to be applied in a wide range of real-world applications, from image recognition to natural language processing. Neural networks have found a wide range of applications in various fields. They are used in image recognition, natural language processing, speech synthesis, and many more. For example, social media platforms use neural networks for facial recognition in photos. In healthcare, neural networks assist in diagnosing diseases from medical images. They are also used in financial modeling, fraud detection, and self-driving cars. The ability of neural networks to learn complex patterns from data makes them invaluable in these applications. These are just a few examples of how neural networks are being used to solve real-world problems. As research and development in this field continue, we can expect to see even more innovative applications of neural networks in the future. Section 5. Image recognition and computer vision. One of the most successful applications of neural networks is in image recognition and computer vision. Convolutional neural networks, or CNNs, are specifically designed to process images. They use filters to extract features from images such as edges, corners, and textures. CNNs have revolutionized image classification, object detection, and image segmentation tasks. They are used in self-driving cars to identify pedestrians, traffic lights, and other vehicles. In medical imaging, CNNs help doctors diagnose diseases from X-rays, MRI scans, and CT scans. The ability of CNNs to learn hierarchical representations of images has led to significant advancements in computer vision. They have enabled computers to see and interpret images with remarkable accuracy. Section 6. Natural language processing and understanding. Neural networks have also made significant contributions to the field of natural language processing, or NLP for short. Recurrent neural networks, commonly known as RNNs, are particularly well suited for processing sequential data like text and speech. RNNs can analyze text to understand sentiment, translate languages, and generate natural-sounding text. They are used in virtual assistants, chatbots, and machine translation systems. Their ability to learn from large amounts of text data has enabled breakthroughs in language understanding and generation. With the advancements in deep learning, NLP has witnessed significant progress. Neural networks have made it possible for computers to interact with humans using natural language more effectively. Section 7. The importance of neural networks in AI. Neural networks play a crucial role in the advancement of artificial intelligence. They provide a powerful framework for building intelligent systems that can learn from data, make predictions, and solve complex problems. Their ability to learn from experience, generalize to new situations, and handle high-dimensional data makes them invaluable in AI. Neural networks have enabled breakthroughs in areas such as image recognition, natural language processing, and robotics. They are the driving force behind many AI applications that are transforming various industries. As research and development in this field continue, we can expect neural networks to play an even more significant role in shaping the future of AI. Section 8. Challenges and future directions. Despite their remarkable capabilities, neural networks still face some challenges. One challenge is the need for large amounts of labeled data for training. Another challenge is the lack of transparency in their decision-making process, often referred to as the black box problem. Researchers are actively working on addressing these challenges. New techniques for training neural networks with less data are being developed. Explainable AI, or XAI, aims to make the decision-making process of neural networks more transparent and understandable. Future directions in neural network research include developing more efficient and robust architectures, exploring new learning algorithms, and integrating neural networks with other AI techniques. Section 9. Conclusion: the future of neural networks. Neural networks have come a long way since their inception. They have revolutionized the field of artificial intelligence and have led to remarkable advancements in various applications. From image recognition to natural language processing, neural networks are transforming the way we interact with technology. As research and development in this field continue, we can expect even more innovative applications of neural networks in the future. Neural networks have the potential to solve some of the world's most challenging problems and shape the future of AI. Their ability to learn from data, generalize to new situations, and adapt to changing environments makes them a powerful tool for creating intelligent systems that can benefit humanity.